All right, we're going to start with the rest of the trig functions here. We're going to start by looking at the tangent function. And so we'll start with just a table of values that we know. We're going to use the ones from our unit circle. So if I put in a value like 0, okay, so 0 is the angle that I'm using. Remember, these are angles in radians that we're using to put in. The tangent of 0, well, on my unit circle, 0 is right here at a value of 1, 0. Since tangent is y over x, I've got a y value of 0. So I've got this point here. And then we can do pi over 4, which would be square root of 2 over 2 and square root of 2 over 2. So when I take those and divide them, I get 1. Okay, and then at pi over 2, which is up here at 0, 1, that's going to be undefined because I'm going to be taking 1 divided by 0. So this is undefined, which means at pi over 2, I've got an asymptote. Okay, so I've got this vertical asymptote at pi over 2. Now, the other place I'm going to have a vertical asymptote is at negative pi over 2, which is down here. Okay, and of course, if I go negative pi over 4, I'm going to have a value of negative 1. Okay, and the closer I get to these asymptotes, the higher I'm going to go. Okay, because I'm getting closer and closer to that undefined value. So I'm getting closer and closer to infinity. Okay, so you get this kind of crosses here and then comes down, or approaches there. So this is it. Now it's going to repeat the same pattern on the other side of pi over 2. Okay, so at pi I'd be back at 0. 3/4 pi I'd be down here again. Okay, I'd be up here, and then I have another asymptote over here at 3 pi over 2. Okay, so I'm going to get this repeated pattern over and over and over again. Okay, it'd be over here also. Okay, same repeated pattern. Okay, so some things we can see from this is the period of a tangent function is shorter than the period of our sine and cosine function because it only takes pi to get a full wave in. Okay, there is no min or max value. Okay, the range is the full range of y values, so all real numbers. So there's no amplitude on a tangent function. There's just a period, and these asymptotes are spaced, one period away. Okay, so if we start looking at our shifts here, A affects the steepness. So this is still going to be our movement. Okay, so this is still our y movement multiplier. B, this affects our period. So it's our period divider. C and D still shift our starting point. Okay, so let's look at an example of one that's been shifted. So 3 tangent of 2x. So that means I've got a steepness of 3. So what that means is I'm not shifting at all, so I'm still going to be at 0, 0. But now instead of going over pi over 4 up 1, okay, I'm going to go over half as much. So I'm going to go over pi over 8. Instead of going up 1, I'm going to go up 3. Okay, negative pi over 8, I'd go down 3. Okay, and my period now is half as much, so my period is just pi over 2. The regular period is pi. I'm halving that. So from here, from my start point, I'm going to go half of my period to the left. So half of pi over 2 is pi over 4. That's where one asymptote will be. I'm going to go the other half of my period over the other way. And that's where my other asymptote would be. Okay, and so then every pi over 2 away from my last asymptote will be another asymptote. So pi over 4, if I add another pi over 2 to it, okay, that'll put me at 3 pi over 4. Because this would be, yeah. And there'll be another tangent wave in there. Okay, and that's just going to repeat over and over again, okay, through all these. Okay, so there'd be another asymptote here, another one here, another one here. Okay, let's look at another one. Sometimes it's going to be easier if we just label our own axes. So let's see. My period, I'm going to divide this out. So this is really tangent of 3x minus pi over 3. Amplitude's negative 1/2. So that's going to flip it. So instead of going right and up, I'm going to go right and down. The whole thing's been shifted pi over 3 to the right. So let's just make this pi over 3. Okay, that's going to be my new 0 point because I'm not going up anything because I don't have a d. My period now is going to be pi over 3. So if I go pi over 3 away from here, so let's make this pi over 3. We'll make this pi over 6. So that won't have a dot. This would be 2 pi over 6, 3 pi over 6, which would be pi over 2. So we're counting by pi's over 6, right? So if my period is pi over 3, I need to go pi over 6 this way and pi over 6 this way, and that's where my asymptotes are going to be. Okay, because half my period. So my full wave is pi over 3 long. So if I know where my middle point is, if I go half a period this way and half a period that way, I know where my asymptotes are going to be. Now if I go halfway in between here and here, that's where my first step would be, right? That's like my, if we look at my base function, okay, halfway between my 0 and my asymptote, that's where I put my up movement. So we're going to go halfway, which would be, let's see, pi over 12, 2 pi over 12, 3 pi over 12, which would be pi over 4. 4 pi over 12, 5 pi over 12. Okay, so if I go over this, now instead of going up 1, I'm going to go down half as much. So I'm going to go down a half. Here I'll go up a half. So it's kind of flattened out a little bit. Okay, so we get that. And then, of course, this will be repeated, every pi over 3. So here would be another asymptote, and I could put another wave in here. Okay, and I'm going to have an infinite number of these waves. So that's the tangent function. Cotangent is going to be very similar to this one. If we just make a table for cotangent here, we'll kind of be able to see the differences because now on my unit circle, if I look here, okay, I'm going to have 1, 0. So if I put in 0 into my cotangent, that is going to be when my function is undefined, okay, because I'm taking 1 divided by 0. So that's actually going to be where the asymptote is. So cotangent starts with an asymptote here. My period is still pi away, So at pi, I'll have my other asymptote. Halfway in between pi over 2, which would be up here. That's when we have a value of 1, or of 0, sorry. Because this is 0, 1. So I'm taking x divided by y, so I'll have a 0 there. And of course, halfway between here, I'll have my 1. Okay, so pi over 4. 3 pi over 4. Okay, so this is kind of reversed because pi over 4, okay, I've got square root of 2 over 2 and square root of 2 over 2, which is 1. If I divide these, negative 1 is going to happen over here because I've got a negative x value. So it's kind of like a flipped over tangent function, actually. A flipped over and switched. In fact, we could write this as a transformed tangent function. So the cotangent of x really equals, let's see, so we need to flip our tangent function, and we need to shift it to the right, which means subtract pi over 2. So these are the same thing. Cotangent is just a transformed tangent function. In the same way that a cosine function is a shifted sine function. Okay, it's just been shifted pi over 2 either direction. Or wait, let's see, sine starts like this, cosine starts like this. So really we need to move this to the left, so it should be plus. There we go. Okay, so that's tangent and cotangent. And I'll make a separate video for secant and cosecant.